Okay, so with that, it's my pleasure to welcome Mick, because I try to pronounce your last name well, but I'm trying to avoid mistakes. So welcoming Mick from Stripe, and I think there are some other team members from Stripe here. So it's great to welcome you here. And yeah, I don't know if you wanted to share with us, or it's part of your presentation, sharing with the community, kind of part of your background and so your professional background and something you enjoy doing outside work.
Yeah, so my name is Mick. I am with Stripe for 4.5 years now. I'm now based in New York City, and I guess for my free time now, I intern at a restauant. Last year I took a part-time culinary program, and I've been working at it for 4 or 5 months now. Yeah, during the weekend. It's at a Thai restaurant called Fish Cheeks, if you want to join me on Saturday. My shift, it's 10 to 5 p.m.
Awesome.
All right. So I will share my screen. So we have here my teammate, my tech lead, Brian, and also Juan, who has been a really great partner team, as well as my EM, I think Harshita, Harshita is also here. Yes, so those are Stripe folks. Thank you for joining us. Yes, I'm sharing my slide, and I think you can see my slide here. A second, please.
Yeah, not the slideshow, but yeah, we can see your slides.
Mm-hmm. Can you see my full slide now?
Yeah.
Perfect. All right. So let's get started. So the topic today, it's called Faster End-to-End ML Dev with Flyte. And I want to focus on end-to-end because I think a lot of time when people talk about tooling and focus on this specific aspect of it, sometimes it doesn't really encapsulate the reality of ML development, which it spans more than just training, right? And so the outline here we'll start with prototyping on Notebook, which is like a to-go solution for everyone. And then how I think Notebook become an anti-solution at a certain point, and how we can transit that to Flyte and show the benefits of Flyte in multiple regards. And lastly, how to transit seamlessly to productionization and the results that we see in the limited availability within Stripe. So to get started, so Notebook, it's obviously indispensable in prototyping because it gives quick cycles of feedback. So the interactiveness of it when we get errors and results, and we can incorporate that to guide our development and analysis. And at the same time, I think the other really huge component is low barrier to entry. So you just open the notebooks and there's no additional tooling or knowledge that you have to learn. It's just a reliable shell that always welcome you with open arms and you can always go to. Right. And so, but at a certain point, this reliable tooling will become a problem for you, I think, in the sense that when you have a workflow or computation that is fairly straightforward, it is easy to just use notebooks and to be able to reason about the results. But as you try to squeeze the entire ML workflow within a single notebook, and because of the cell-based executions, where you can execute in a linear order or like out of order, the results that you see from the notebooks, sometimes you ask the question whether this model's Sterling results is actually a result of what you see in your notebook, or rather, or whether there's a different underlying states in the notebooks, right? Because you could have rerun certain cells, you could have forgotten some cells. And as a result, I think when people release models from notebooks, we rarely have high confidence about what it can do, or to be able to trace back to the provenance and the metadata associated with that just from the notebook's cells outcome. And obviously, I think one pattern that a lot of ML engineers would do, it's just to refresh everything, start from the beginning, and we'll get the fresh states there. And of course, the cost there is really high just because the entire ML workflow involves maybe feature engineering that takes a lot of time, and of course the training itself. And lastly, I think maybe this is a secondary concern because I think new technology now like Ray or better integrations with big compute tooling to notebook is available. But a lot of time when you get started and you want to scale with compute, notebook isn't the primary solution for you. And unless you do more non-trivial integrations that you'll be able to get that compute resource in notebooks. So at a certain point, I think notebook become an anti-solutions, and that's when I think we should look for different solutions to enable developers to productively and reliably run their ML experiments in a reproducible fashion. So transiting to Flyte with ease. So there's a part of Flyte workflow authoring. So what does it mean when one wants to use Flyte? So if you look at the image below, on the left side, it's task that, oh no, on the left side, it should be without the annotations. My apologies here. So what I'm trying to say is on the left and the right side, the code is exactly the same. The difference should be just on the right side, it has a task annotation. So that's how you would make your vanilla Python code into Flyte task. And I think compared to other orchestration tooling, we use Airflow and we still use the old version, but the orchestration, it's in those frameworks is not testable software. It is a separate decoupled DSLs that the developer has to do context switching between the business logic within your Python code and the orchestration logic that string those tasks together in a particular DAG. And while there's a benefit in decoupling them and ability to add more sort of annotations or metadata to help with operations in the Airflow case, for example, in the old version of the Airflow that we use. But we find that having the benefit of having expressive Pythonic code to write your orchestration logic together with your business logic. And in a way, and actually engineers won't actually realize that. I think that's a great experience when you actually write a software that is expressive, that captures your intention, and you leave the orchestrations, DAG constructions to Flyte. So I think in Flyte's documentation, you would call it like declarative workflow. And I think that's exactly what our users is benefiting a lot, moving from both Airflow and also moving from notebooks where the cost of conversion here is just a decorator. Although I would lie, there's zero differences. So there's the small difference of promise abstractions that so a vanilla Python code, once you change it to Flyte, the results will be evaluated as promises, but there's a small learning curve there. But mostly your code should be able to run just fine by just after changing this annotation. Pausing at this point, is there anyone want to intercept or feedback, input, questions? All right. Right. So once we have our code in Flyte, right? How do we actually make it known to Flyte? This is when registration comes in. And I think this is the core part that makes experiments scientific. Scientific here means that it is reproducible. You're able to trace back what you ran, and you can rerun it again to give reproducible results. So at Stripe, we use Git SHA from the branch as a Flyte version as you as you register. So this gives a very natural experience to product engineering, where they make a features, they would commit, and those are reliable trace of their work, and they are able to go back to flash commits and see exactly what the business logic was supposed to do. So similarly, when you do Flyte registrations based on your Git commit here, you can go through different versions and you can trace back to your code in your repository just to understand what exactly was written there and how that could explain the results that you're seeing. And in terms of resource organization, because the registrations here would archive your code as a container image. So the code is frozen in version, right? And this is decoupled from execution in the data. So compared to notebooks where the code and execution, it's in the same abstractions of notebook run and notebook UI. In Flyte, you have a separate workflow, and one workflow you can launch multiple executions with different parameters, with different inputs, or you can just run the same workflow with the same input, but maybe your code by nature of machine learning, it's non-deterministic by design, and you just want to get multiple results from this, this registered code. And lastly, as a real scientific experiments, if you have friends doing like wet lab, when they, the temperatures of the culture goes up and power goes out, they have to transfer the culture into a different fridge, different lab. Running real experiments on Flyte, you will come into an unexpected outage because of, let's say, the delegated compute system that you're talking to. And you want to be able to intervene the experiment. You want to be able to manage, retry, abort, begin again, right? And these are available tooling that Flyte UI allows you to manage your real scientific experiments. Then, so now when you have a basis for running a real scientific experiment, we want to talk about how we can improve the speed. And I think one killer feature that Flyte enables this as a first-class abstractions is caching. If you look at the code snippet there at the task annotation, you see cache is equal to true, and with some cache version. So imagine like we have a large workflow, and as a good software engineer, you would make changes or fine tune targeted of a modular component within your workflow. And if you were to do that within notebooks, you might have to, like, maybe you want to run just a single cell, but I think this goes back to my previous example, my previous point, which is really hard for you to keep track of, cell-based execution, where you decide to change one cell and execute it. But are you sure that you didn't accidentally change the other cells to be able to reuse the old states? But here, the caching is a first-class abstractions. And once you add this annotation there, Flyte will understand based on the cache key, which is computed based on the signature of the method and the version there, and the combination of the input variables, that these tasks have already been computed. So you can actually confidently run the entire workflow and let task compute and decide which ones can be fully cached and reuse the previous results. And this saves a lot of time. So our users have expressed a lot of joy in running the experiments just because they're able to get the results much faster. Next, well, so we know how to iterate fast. Do we know how to iterate together in an efficient and peaceful manner? By this, I mean that Flyte's team-level caching saves compute. So relying on, based on what I just said about caching that Flyte enables here, so multiple teams can run the same workflow, but they can branch off to do to experiment with their own features. But the upstream tasks that their work stream rely on might be exactly the same, and they're able to rely on the caching results that other team members have already generated. So this allows collaborative work and saves compute. And lastly, I think Flyte elegantly used Kubernetes resource quota per namespace very well. And especially where the Flyte resource organizations, it's divided into project and domain, and that maps to the namespace. This allows us to manage the resource quota transparently based on Kubernetes resource quota abstractions. So what does this actually mean for the team is that they're able to tell us, the infra team, how much quota do they want within their team, and they're able to negotiate within their team how they want to use this quota. And also, if they want to increase the quota, they'll be able to ask for business justifications on how much, why do they think this larger compute would translate to business insights or some features that the team actually wants to achieve. So with this, so the peaceful part is that, team, once we have a team level resource quota, there's less problems in terms of resource contention across teams. So as an infra team, I think that's one good guardrail to support multiple teams running on the same infrastructure. Lastly, so now we have iterated collaboratively, efficiently, peacefully, fast, right? Now let's transit to productionization. So how do we transit from that iterative development into actual productionization? So at Stripe, we schedule the Flyte workflow on Airflow. That's mainly because a lot of our data engineering pipeline is on Airflow, and the upstream data set to Flyte workflow is actually from Airflow, and that's why we decided that it's functionally it suits there. And I think but the benefit here is that there's no code transformation between dev workflow and prod. The distinction here is really you just register. I mean, you can actually use the same code, the same container image, or the same Flyte workflow resource, but actually at Stripe, we make some distinctions where when we do at dev, that is reserved purely for ad hoc development. And when you actually want to go into scheduling on Airflow, you would register under a prod domain. And over here, use Python FlyteKit SDK to write our own Airflow abstraction for Flyte task. So in this way, a Flyte workflow is a node within Airflow DAG. And we create the execution ID prefix with Airflow, so that's easily distinguishable from other ad hoc workflows. And this pattern has been good for us when people want to do auto training and auto training and auto deploying of models. So let's see results at Stripe in limited availability. So this is results based on a single team where we see 10x more offline training jobs dispatched from Flyte. And that results in 5x more frequent model releases with sizable business gain. So I think the realization here is that ML productivity is not nice to have, but it's actually a business requirement. And I think this is similar to Dan's comment about feature is not nice to have, but it's a feature, right? In your earlier slide. And I think, yeah, on a similar vein, I guess, ML productivity for us in particular, we have many use case, which is adversarial. And to be able to react to that, respond to incidents in a timely manner, it's actually critical to business survival. And Flyte does enable this quick model experimentations and release. So we talked about all the Flyte from our ML development parts. I want to talk about the infra part, which is I am from ML team and Brian's here. It's such a joy to work with a Union AI team and also with Flyte software artifacts. For example, it supports multiple Kubernetes clusters seamlessly. The services are modular, decoupled, and we are able to deploy the control plane in our internal service deployment and the core data plane on the Kubernetes. And obviously, the critical part is the world-class engineering team giving feedback to us to inform our architectural design, and we look forward to working with the team. And shameless plug, in my infra at Stripe is hiring. So go to stripe.com/jobs. Thank you. Any questions?
That was awesome. Thank you, Mick. Any question, comment?
That was an amazing presentation. I have one question. So that was not a shameless plug. I think I don't know, David, if you agree, but we should allow people to post jobs related to Flyte in the Flyte Slack channel.
Yeah,
So,
it's open. Let me put the link here.
Yeah, please do. Please post them. And one other question over here. You've seen the adoption in Flyte. Is there more demand? How is that going to grow? Like, what are you guys planning?
Yeah, there's definitely demand within Stripe to use the product. I think we are, as we've shared with you, we're migrating to EKS, and with security requirements internally that we have to implement, and user identity and workload isolation, that is the blocker. And we look forward to working with you more to help us to deliver that. Yeah. And people will be so ecstatic. Like, you can't imagine, I spend so much time talking to users that please hold on, that we want that our infra is not ready yet. We still want to iterate, and we have to sadly reject them from onboarding to Flyte. So it's a great product, everyone. Please use Flyte.
Thank you. That probably is it, right? Right? Just write a blog and it'll help us a lot, the entire community. doing this video really helps the community, because we understand and we see, and you put many of the points very eloquently. So highly, I'm obliged. Thank you. Any other question?
Yeah, just a quick question/comment about something you raised about kind of like the learning curve. There's like what I call the uncanny valley. It's like it's almost there. It's like almost Python, but there's like a few gotchas. So if there's anything specifically you'd like to kind of call out as an issue, yeah, we'd love to. We're like constantly trying to close that gap. I mean, there's always going to be a gap, I think, but yeah, if we can make that gap as small as possible and raise errors or warnings when things kind of veer off from your regular Python expectations, yeah, would love to know what those are. We kind of know what those things are, but it's always good to have external validation.
Noted. I am not developing Flyte day to day, but I think our user team has been fantastic in giving feedback. Steph and Juan. And Juan, I don't want to put you on the spot, but only if you have issues that would definitely get attention from Flyte team here, if you want to share, only if you have any at this point. Oh, Juan does. Yay.
Hello. Yeah, definitely big fan of Flyte. I'm on the team with that graph where we just exploded our experimentation velocity. You saw there. Is really excited to use it. Yeah, I think the comment on like promises and kind of, I've noticed it takes a little bit for people to kind of get used to them. I think two things come to mind. One, I found like we've gotten used to some of the error messages, but I think initially they can be a little not intuitive, especially as you're starting and you go try to interact with a promise, and then it's kind of like, oh, a promise doesn't have a get function or something like that, and it's like, wait, what does that even mean, right? Like it doesn't really click until you're like, actually, you can't really interact with promises at all. So a little bit of like more usability on the errors, I think would help guide people early on when they're not familiar with them. And then just secondly, I think we're super excited for like I think there's been some chats around eager mode and maybe kind of like being able to resolve those promises quicker so that people don't really have to think about them too much. We're just super excited to get to use that and to try that.
Awesome. Cool. Yeah. Eager mode is something we're working on, hopefully having an experimental kind of submodule in Flyte so you can start, using it and giving it a shot. Which does make me think we should have like a roast Flyte kind of segment.
We should.
Just so we can like surface a lot of these sooner.
Yeah, I have a lot of roasts myself, so. Anybody else have any questions?
I have a question.
Oh, yeah, hey, but go for it.
Hey, so since you guys have exploded your the model runs that you've done, I just want to know, like, are you able to like reuse workflow components across those different modeling use cases? And maybe talk about like, I don't know if there's like a set of modeling tools you're using, like XGBoost on Spark. Like, yeah, because anyways, yeah, that's my question. Yeah.
Yeah, so we're sort of in the process of like, I think there's a lot of kind of little utilities and tools that we've built that some of the teams are trying to reuse, and we're trying to figure out, kind of ownership and like who should maintain those and that kind of stuff. So I think that like we're in the process of figuring that out. In terms of kind of like particular models, like definitely big users of like XGBoost, transformers, neural nets, and like ensembles of all of them. So I think that like we're mostly trying to reuse the utilities that we've built to help us kind of interact and like communicate with different services, like send particular data jobs to Spark and like bring them back and get results. I think that in terms of kind of across different models, we do like what we did. Our first project was like rewriting our experimentation rails on Flyte, and like all of our models are trained on Flyte, and they're trained side to side, and they share the same like feature computation, they share the same like training workflows. And so like now we're going into adding new models to it, and it's been really nice to be able to just say like, okay, I'm going to add a new model. I know I need to do like, I can reuse these features, I can reuse these training workflows and these evaluation reports, for example. And so it's been really great and productive that way.
I think what's really great is because Flyte task, it's Python code. So in terms of like reusing components, it follows standard software engineering practices where if you want to like create a utils libraries and people can reuse them in a standard way. But I think what it's perhaps going to be for us to think further, it's when the backend plugin it's used at Stripe. That's where you have higher level of abstractions of managing the computation, how the Flyte code in under task is being run, and how the backend managed the entire life cycle of it. I think that may require, we haven't thought fully about it, but I think it's slightly a different, like simple low barrier of entry of like contributing to code. So that's where I'm curious if Keenan has more thoughts to it.
Yeah, I think, and that's why where the Python backend plugins will really help you further. We already have backend plugins in Go, but the goal of backend plugins has always been to cleanly separate what the users of the Flyte system should be doing and what the maintainers or the operators or the administrators or the infra people, right, like are doing. That way you can keep on, upgrading the functionality, adding new capabilities, switching service providers if need be, all with the backend. And the beauty of the backend plugin is that you don't need to run a pod. It runs within like a simple service. So the cost dramatically drops. The performance also increases quite a bit. And the number of concurrent workflows can, on a single Flyte instance, can go up to hundreds of thousands, as Spotify and like some others have done. And so it scales really, really well. So I would I think we've talked about this in the past for some of your systems, and it's a great way to integrate without really opening up any of your integrations to the in the open source, because it's completely, you don't have to release it or anything. You can keep it with yourself internally, and if you feel that you're integrating with, let's say, OpenAI, and you want to release that out to the world, you can. So that would be great. Hopefully that answers your question.
All right. Well, thank you, Meg, and the entire team at Stripe for this fantastic presentation. Any other comment, question so far? Nope.
I have one more question.
Yeah.
So you've had success at Stripe with Flyte, which is really exciting. I was just wondering, like, when you show up with a great new tool, I was wondering, like, if there was any pushback that you could surface. Sometimes there's always like people like, whoa, this is new, it's doing something different. That's always useful for us to hear.
Yeah. Brian, only if you, I don't want to put you on the spot, but I think you are more qualified than I am. If you want to talk about the initial phase of bringing flights and, like arguing with Airflow, that's right.
I wouldn't say that we were arguing, but I think what helped make Flyte successful was a really like early and deep partnership with the users, especially like Juan's team. They were a huge proponent in terms of pushing for Flyte as a product. I think we went through the initial phase of trying out a bunch of different workflow engine tools, and Flyte just won out in terms of feature capability. We created a bunch of buy versus build type of documents. Ran that through effectively our executive sponsors. And then we got buy-in from our partners as well as our leads. So from there, it was actually kind of like proving out that we're kind of like flexing our muscles in terms of adopting basically third-party tooling and open source tooling. So I think that was a good exercise for us as a whole. And yeah, that's primarily how we got it incorporated.
Thank you, Brian.
Awesome. Thank you. Thank you all. That was fantastic.